So what if there is an AI that goes beyond chatting and actually get the work done on your machine? Running the commands, organizing the file, fixing the configuration, and interacting with your tools like the real technical assistant sitting right next to you. That is OpenClaw. Most of the AI tools like ChatGPT, Claude, Gemini are great at conversation, but you still do all the work manually. OpenClaw flips that around. It executes the script, call the tools, run the diagnosis, and orchestrate the local agent, all on your computer without sending data to any cloud. So in this video, I'm going to cut the hype and show you exactly how to use this tool step by step. We'll install OpenClaw, connect it to free AI model, then understand how OpenClaw works behind the scene and explore the skills and MCP servers. And finally, hook it up into a real tool, in my case NetBox for network infrastructure, but the same pattern works for any other use case you have it, be it GitHub, Slack or database. So by the end of this video, we'll ask a simple questions and get back the real data from the actual system. But here is the real power. I could say alert me if something goes down or run the backup every night, and it actually does. Not just answering but taking action 24/7. So please stick around to the end. I'll show you how to connect this to your tools and workflow practically. So let's get into it. Alright, before we run the installer, let's quickly verify our system. OpenClaw requires Node.js 22 or higher. So we'll start by checking the OS and the runtime versions. So I'll run the basic checks here, and you can see we are running Ubuntu 22.04 and both Node and NPM meet our requirements. Perfect, we are good to proceed. Now a quick note before installing, it is not recommended to install OpenClaw directly on your personal computer. Remember, OpenClaw can execute commands, access files, run script, and interact with your system tools. Running it in a VPS or an isolated VM keeps your local file, SSH keys, and personal data completely safe. So in my case, I'm running this in a virtual host inside my EVNG platform, completely sandboxed mine machine. And if you want to see how to build this environment from scratch, I already have a dedicated video on that. I'll tag it here for you. Alright, let's kickstart the installation. I'm going to open my browser, head over to openclaw.ai. This is an official website for OpenClaw, and they made installation process fairly straightforward. On the home page, scroll down the Kickstart section and you will see the installation command, and next to that there is a change button that will let you switch the operating system. They support macOS, Linux and Windows. Since we are running Ubuntu on our lab, I'll click change to Linux. The installation command updates automatically. It's a simple curl command that downloads and runs the installer script. So let me copy that and switch over to our terminal. Now let's run the installer command we copied. The script detects we are on Linux. Check the Node.js version, then install the OpenClaw package globally. So after the installation, it launches a setup wizard. First thing, you will see a security warning. Since this is my local lab, I'll confirm and continue. Next, it asks for the onboarding mode. I'm choosing Quick Start because it applies all the recommended default, gateway on port 18789, bound to localhost, and secure with token. Now here is where it gets interesting. Now the setup wizard asks to pick up the model provider. You will see options like Anthropic, OpenAI, Moonshot AI and more. I'm choosing OpenRouter because it gives you a universal API key that works with many models. Claude, GPT-4, Mistral, everything in one place. And the biggest advantage is they offer free models, which is perfect for testing OpenClaw. So let's pause the installer and open the new tab. Head over to openrouter.ai, log in with your Google or GitHub. Then we'll go to the key page and click create. Let's give a name, OpenClaw integration, set an expiry time if you want to. Click create to generate an API key. So before we go back to the installer, let me show you how to find a free model. In OpenRouter, go to the model section. You will see all the major models here. Let's filter with the free version here. This filter will show only the models that won't cost anything. So for this demo, I'll use GLM-4.5.air, a solid free model that works well with the tool calling. Perfect. Now let's go back to our terminal and continue with the setup wizard. Next, it is asking how we want to provide the API key. Select the paste API key now and paste that OpenRouter API key we just copied. The wizard confirms the model it's configured with OpenRouter/auto by default. So we want to use our specific free model. So let's copy the model name from the OpenRouter and update it here. Next, it asks about the channel, Telegram, Discord, WhatsApp, Signal. These are how it communicates to your bot from the different platform. For now, let's select skip for now. We can always add the channel later. For the skills configuration, I'm going to show you how to add a custom skills during the second part of this video. So let's skip that for now. And the hooks and hatch new bot, we'll do it later. Great, we are done with all the essential configuration for the gateway. The installer now shows the onboarding of the gateway is complete. It also gives you a dashboard link where you can manage the OpenClaw from GUI. At this point, we can use all the OpenClaw commands directly from the terminal. And if you get command not found error, it means that your system is in picking the npm global install path. So just update the path like this. Alright, before you jump into the OpenClaw dashboard, let me show you a few built-in diagnosis tools. First one is OpenClaw Doctor. This command checks your installation for common issues like missing the dependencies, permission problems, or configuration errors. If anything is wrong, you can fix most of them automatically using the fix options. It applies recommended fixes and clean up any broken setup. Next, if you want OpenClaw to run in the background, start the daemon. This keeps the gateway active as your tools and agents can connect at any time. Now let's open the dashboard. The dashboard command spawns the URL that include your access token. Just copy that link and open it in the browser. It works perfectly even in remote or headless environment. Alright, so here we are the OpenClaw dashboard, localhost :18789. This is the default port to launch OpenClaw. On the top right corner, we can see the current software version plus the green health OK indicator. That means everything is running perfectly. So before we dive deeper, let me give you a quick tour of OpenClaw dashboard. The chat tab is your main workspace. Your agent is already awake and asking for the identity details. You can customize his name, personality, emoji right here. Also notice the built-in commands like /clear or /new to reset or start the fresh conversation. Next is the overview tab. This is your system health panel. It shows the WebSocket URL, gateway token, uptime and overall status. If the agent stops responding or the gateway fails, this is the first place to check. Then we'll move on to agent tab. This shows all the configured AI agent. Right here I've got a single agent named main, which is default, and using the free GLM model with all the available skills enabled. You can easily create a separate agent with a different model and permission depending upon the task you want to handle. Now the most interesting part is the skill. OpenClaw comes with more than 50 built-in skills automatically enabled. Out of the box you will get the tools like GitHub, Docker, database, bash commands and more. Alright, now we'll jump into the most exciting part of this video. So before we plug anything, let's understand how OpenClaw actually works and what is happening behind the scene. Once you understand this part, you will realize something powerful. You can connect OpenClaw to almost anything. So imagine this. You open the dashboard and type, "What is the weather in London?" or "Organize my download folder." Pretty simple, right? But have you ever thought about what actually happening next? Your tools, whether APIs, file system, database, don't understand the natural language. They expect something like API calls, authentication token, script, or the specific command. And that's exactly where OpenClaw comes in. OpenClaw acts as a gateway, a translator sitting between you and your tools. You talk in natural language, OpenClaw translates into an action your tools can understand. But here is a part that makes OpenClaw different from tools like ChatGPT or Claude. Most of the chatbots follow the simple pattern. They think once, respond once, that's it. But OpenClaw runs something called React Loop. React stands for reasons, act, and verify. Here is what that means. The AI reasons about what needs to be done. It takes an action, then verify whether the action worked. If the task isn't completed, it repeats the loop. It keeps going until the job actually finishes. So this isn't just a chatbot responding to you. This is an AI agent actively working for you. Now the big question comes, how does OpenClaw actually know how to do the things you asked for? It learned through two main systems, skills and MCP. Let's break those down. First, skill. Skills are the simplest way to teach OpenClaw the new capabilities. A skill is basically a text prompt that explains how to perform a task. Think of a skill like a recipe card. When you follow a recipe, it tells you what ingredient to use, what step to follow, how long to cook something. A skill works exactly the same way. Technically, a skill is just a markdown text file that says, so when someone asks about this task, here is exactly how to handle it. Let's look at the simple example. Imagine you want your AI to check the weather. You could create a skill that says something like, when user asks about weather, run this curl command to this weather API. Pass the city name as the parameters. Use this API key and extract the temperature from the temp field. That's it. It's basically a plain English instruction combined with the technical commands. When the user asks about the weather, the AI finds the relevant skills, read the instructions, execute the command, and return the result. The best part, you can create a new skills in few minutes. It's just a text file. Drop it in the skill folder, boom. Your AI just learned a new ability. OpenClaw actually comes with the 51 built-in skills out of the box. If you want more, you can explore Claw Hub, which is basically a community library for shared skills. Now there is a second way to give your AI a new abilities. It's called MCP, which stands for Model Context Protocol. With these skills, you teach AI how to perform a task. But with MCP, you give AI a ready-made tool that already know how to do the task. So let me explain with a simple example. Imagine you want someone to make a coffee. With the skills, you hand them a recipe. You say boil the water to 95 degree, grind 18 grams of beans, pour the water slowly in circles, wait for 4 minutes, they read the instruction and perform each step. But with MCP, instead of recipe, you give them a coffee machine. They press one button, the machine handles everything, coffee is ready. Same result, you still get a coffee. But the approach requires reading and executing the instruction while the other simply runs a specialized tool. Now here is the interesting part. You don't have to choose between skills and MCP. You can either one off by itself or you can combine them. That's where something called MCP Porter comes in. Think of MCP Porter as a bridge. It connects MCP server to the OpenClaw, but the OpenClaw doesn't automatically know that MCP Porter exists. So you write a skill that teaches that AI about it. So here is the workflow look like. You ask, organize my download folder and tell what do you move. So behind the scene, OpenClaw reads the skills. The skill says, for file operation, use MCP Porter to call the file system MCP server. That skills trigger an MCP Porter. The MCP Porter calls the MCP server. The MCP server performs the actual task, organize the files. The result come back through the chain. You receive a clean summary of what happened. So in this setup, the skills provide the knowledge. It tells OpenClaw what tool exists and when to use them, and the MCP provide the muscles. It performs the task reliably. Now the question comes, which one should you use? So here is a simple way to think about it. If you need something quick and custom, write a skill. If you need something powerful and reliable, use MCP server. If you want serious automation, combine both. Skills provide the knowledge, MCP provide the muscle, and together they create a real automation. That's exactly we are going to set up next. Alright, enough on the theory, let's build this thing step by step. We are going from zero to fully working setup. First, we'll set up the MCP server from scratch, configure the MCP Porter to bridge it, and create a custom skill to tie all together. This is going to be a complete custom setup. So once you learn this flow, you can apply it to any tool you want. So let's start building. So in this example, we are going to connect to a NetBox, which is a web-based tool for infrastructure management. I have these tools running in Docker in my local network on a separate host. And if you want to know how to set this up, I have a complete video uploaded in this channel. And we'll go to the devices. You can see a couple of network devices listed over here. And here is our goal. Instead of manually calling APIs or logging to the UI, we want to query this data using the natural language through OpenClaw. So imagine asking like list all devices in NetBox, show all my IP address, or give me a summary of network infrastructure. The OpenClaw will automatically query the NetBox and return the data. To make this happen, we need to install something called MCP server for NetBox. So let's walk through this setup step by step. First, we need to install UV. UV is a Python package manager and the NetBox MCP server uses to manage the dependencies. So in the terminal, run this command, then load the environment. And here you can see UV is installed successfully. Great. Moving on, now we need to install the MCP server. For that, let's download the latest MCP server first. So let's navigate to NetBox lab site and go to the community page. Here you can find the GitHub page. So search for the MCP in the GitHub and you will find the NetBox MCP server. So let's copy this clone URL. Back in the terminal, let's clone the repository. Let's clone the MCP server. It's almost download immediately. And you can see a new directory created for NetBox MCP and we have all the files and folder listed. Great, now we have the MCP server ready. Next, we need to configure the connection parameter for our NetBox instance. So we'll update .env file. It contains two things, the NetBox URL with the port number and the API token, which is generated from the NetBox UI under the user profile. Now come to the final piece of UV. Let's do the UV sync, which will load all the packages required for the MCP server, like fastMCP, PyYAML, and other dependencies. And finally, MCP run command to run the MCP server. So you should see something like this, starting the MCP server NetBox with the transport stdio. Great, that means NetBox MCP server is now running. I'll leave this terminal running. Now let's go to the next step of this demo where we'll install the MCP porter. For this, let's open another terminal. Remember, all these are loaded on the VM where we have the OpenClaw running. First, let's install the MCP porter globally using the npm. It's fairly quick. Then verify using the MCP port -version command. Next, we need to tell the MCP porter how to start our NetBox MCP server. For this, create a configuration directory inside the NetBox MCP folder and we'll name it as config. In that, we'll create an MCP porter.json file where we'll put all the configuration details, which basically tells when someone asks for the NetBox MCP server, run this using the UV in this directory. We do not include any credentials here because these are already stored in the .env file inside the NetBox MCP project. Let's also create an environment variable named mcp_config point to this MCP port.json file. Great, let's quickly check if MCP porter can actually see our server. So use MCP porter list command and we should see something like this. Discovering one server, that is NetBox, with the 4 tools attached and status shows healthy. Perfect. Now if you want to do a detailed check of each of those tools, you can use MCP tool command. I'm just sharing these commands in case you experience issues while you're building your own agent with your tools, and this will help to troubleshoot each step. Now you can see a lot of details here, but on a high level you see a couple of tools highlighted and details on how it works. Now one more interesting command on MCP porter, which is call, where you can call specific tool object. And look at the result. We get all the device details from NetBox passed in JSON with its platform and other associated details. And these tests make sure that everything is working perfectly from terminal before we jump into the actual OpenClaw dashboard. Right, now we will look at how OpenClaw discover our MCP porter. That's the last piece of configuration we need for the agents. So here is the current OpenClaw configuration. So before we edit anything, let's create a backup of this configuration file. This is important one. Now we'll use Python and update the env section of this file, which is essentially perform 2 actions. First, update the path variable, include the UV binary and points the mcp_config variable to the MCP porter configuration we just created. So let's quickly verify the configuration using the cat command. And if you are curious to know where is this updated on the OpenClaw, you will find these details on the last section of the configuration file. Now the most interesting part, let's see how to create the NetBox skills. These are additional reliability. This allows OpenClaw to query the NetBox directly using the curl if the MCP isn't available. So let's create the NetBox directory first inside the workspace under the skill folder. Then create a skill file called skill.md inside the newly created NetBox folder. Let's give a name and the description of the skills. Then the instruction follow, they query the NetBox on so and so IP address using the curl. Then share the actual curl command with access token details for the API access on the bash. Then provide the common endpoint like devices, IP, site, etc. So in a nutshell, these steps create NetBox skills that define the API access instruction using curl. It allows OpenClaw to query the NetBox directly and provide a fallback integration alongside of MCP. Great, finally we'll restart the OpenClaw gateway to effect these changes on the configuration file. Status shows Open Gateway loaded, active and running. Now let's do a quick check if skills loaded correctly. So use OpenClaw skill set command and filter for NetBox. It shows ready for calling NetBox for network infrastructure tool. Great, so we have created MCP server, plugged into MCP porter, then added to the skills. Now let's see this in action on OpenClaw UI. So let's start the OpenClaw dashboard here and let's fire up the browser. On the chat tab, first we'll type list all devices in NetBox as a general query. And immediately it will get back all devices including the device name, its site details, role, IP address and more, all coming directly from NetBox. And you see these details populated on NetBox from our home lab infrastructure. Now let's ask something more interesting. We'll check the IPAM capabilities. So we'll ask, hey, list all IP address on NetBox. This is a good check if you want to find out free IP address for assignment or audit purpose. Boom, there you go. It first lists all the loopbacks, then show the device IPs, and it also shows which device and interface this particular IP is assigned to. Very well documented. Now let's do a holistic check. Let's imagine I am new to a particular interface and want to have a quick overview about my infrastructure. So let's ask this question to the OpenClaw. Give me a summary of my network infrastructure. Instead of dumping the raw JSON, AI actually analyzes the data and gives a proper summary. First, it generates a quick network overview about the sites, tenants, subnet details. Then it goes to the individual device level and gives the output. That's the difference between the manual API calls and the AI agent that actually working for you. You could add Telegram or Discord as a channel, and suddenly you have 24/7 network assistant you can message from your phone. So imagine sitting on your couch and asking, "Hey, are all my devices online?" and OpenClaw check the NetBox and replace instantly. You can also plug into more MCP servers like GitHub, Slack, database, or even Ansible automation. The skills and the MCP ecosystem is growing really fast. So once you understand this pattern, you can basically connect OpenClaw to anything. All the commands and the configuration for this video are available on GitHub repository, link in the description. I also included all the commands we have discussed in this video along with a troubleshooting guide with the common issues and fixes to help you get this thing running smoothly. And that's it for this video. If you found this helpful, make sure to hit the like button and subscribe for more content in the automation and AI space. And if you managed to get this running, drop a comment and let me know. I would like to hear about your setup. And if you run into any issues, leave a question below. I'll do my best to help. Thanks for watching. I'll see you in the next one. Take care.